Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
For this video, I'm going to cover AS Topic 8, Transport in Mammal. I'm going to focus on the heart, where I'm going to describe the process of cardiac cycle, which includes the atrial systole, ventricular systole, and the process of diastole. And I'll include a question related to blood pressure change during the systole and diastole. To ease the process of understanding, I will illustrate the cardiac cycle in a table. And just remember, one cardiac cycle actually represents one heartbeat, and it also represents one pulse. So let's start with our heart contraction. We usually start with atrial systole. So another word for systole also means it's contract. So what is actually happening during atrial systole? To illustrate the process of atrial systole, sometimes from the diagram, you can see some clue where you will see that the atrial wall is slightly contracted. So indicating that the atrial wall muscle is actually contracting. And at the same time, the ventricular wall muscle is actually relaxing, filling up with blood from atrium. So at this point, the AV valve, AV valve that is located between the atrium and ventricle. If you want to be specific, the left side one is known as bicuspid and the right side one is tricuspid. So the valve will be open, while semilunar valve that is not in use at this point of time will be closed. So what is happening to the blood flow at this point? Since the wall is contracting, so the blood will be pushed from the atrium into the ventricle. So when the ventricle is full with blood, this is where we will move on to the next stage, which is ventricular systole. During ventricular systole, one of the prominent features of the ventricle wall will be the muscle will be contracted, therefore it looks a bit narrow. So what is happening to the atrial wall muscle? At this point, the atrial wall muscle is relaxed, waiting to be filled up with blood from the vein, while since it's a ventricular systole, obviously the ventricle will be contracting. So when the ventricle wall muscle is contracting, the blood will be forced out of the ventricle from base upwards. So there's a tendency that the blood is going to be forced back into the atrium. So to prevent this from happening, the AV valve have to close. So when the AV valve closes, that's where it produces a sound. And this is your first heart sound, which is known as loud. This is to prevent backflow into the atria. For semilunar valve, it has to be open so that the blood can flow out into the pulmonary artery to the lung, and for the left side will be into the aorta to the whole body. So the blood flow, we're going to describe it as out of ventricle into the lung and whole body. So during ventricular systole, what is actually happening to the atria? Since the atria is actually relaxing, so the blood pressure is low, blood is actually filling in from the veins, such as the vena cava and pulmonary vein, into the atrium. The blood pressure in the atrium is actually increasing as blood is filling in. At the end of ventricular systole, the ventricle is actually empty, as all the blood is pumped out of the ventricle and they're traveling away from the heart. So at this point, the atrial wall muscle is relaxing. Ventricular wall muscle is also relaxing. And what is actually happening to the AV valve? So AV valve will be open as the blood will be filling in from the vein into the atrium and into the ventricle. Because as the ventricle is empty, the blood pressure of the ventricle is actually lower than the atrium. So blood will start to fill in from the veins into the atrium and into the ventricle. So AV valve has to be open, while semilunar valve has to be closed to prevent backflow into the ventricle. Blood that is in the aorta and pulmonary arteries are not allowed to come back into the semilunar valve. So it has to be closed. And this will result in the second heart sound, which is known as duck. So blood is filling up from the vein into the atria and into the ventricle. And when the ventricle is almost 70% full, that's where the next cardiac cycle will start again, where atrial wall muscle will start to contract. So always when you are describing about cardiac cycle, don't forget to include all these criteria indicating if the muscles are currently contracting or relaxing, what is happening to the valve, and the direction of blood flow. And one thing to note is, every time before you mention about the valve opening or closing, make sure you compare the pressure difference, because it's the pressure that actually forces the valve to open and close. So for example, when atrial wall muscle contracts, the blood pressure of the atrium is actually more than the blood pressure in the ventricle. This will cause the AV valve to open. And during ventricular systole, when the blood pressure in the ventricle is actually higher than the atrium, this will cause the AV valve to close to prevent backflow into the atrium. And when both atrium and ventricles are relaxing, the blood pressure in the ventricle is now lower than the blood pressure in the atrium. Therefore, AV valve will open once again to allow the blood to flow in from the atrium into the ventricle. So let's relate to the pressure change during cardiac cycle. So first thing, we need to identify which line represents the pressure of the atrium and which line represents the pressure of the ventricle and the artery. So always remember, the atria will have the lowest pressure always. So this dotted line will represent the atrial pressure. And the line that shows drastic pressure change will be your ventricular pressure. And the line that always has the highest pressure among all will be the artery or the aorta pressure. So which stage or at which point it indicates atrial systole? When the pressure of the atria starts to increase, which is this part, this will be the atrial systole. So the answer will be B, as it shows that the atrial pressure is increasing. So what if question asks about ventricular systole? So when you see that there's a sudden surge in the pressure graph for ventricle, you know this represents ventricular systole. And when the ventricle pressure starts to drop, this indicates the beginning of diastole. So how do we identify which area or which point represents the valve opening or closing? So the best clue here is look at every intersection of the graph. So at this point C, where there is an intersection between the red and the blue line, so it definitely represents the AV valve because it's between the atrium and ventricle. So the blue color line shows that ventricle pressure is higher than the atrial pressure. So AV valve has to close to prevent backflow. When the blood pressure of the ventricle is higher than the arteries, at this intersection, this will represent the semi-lunar valve, and it has to open to allow the blood to leave the ventricle into the arteries. And during diastole, this is the beginning of diastole, where you see the pressure of the ventricle is decreasing. Again, this is semi-lunar because it's an intersection between the ventricle and the arteries. So semi-lunar valve has to close to prevent backflow of blood from the artery into the ventricle. And the last intersection here shows that this is AV valve. When the pressure of the artery is increasing as blood is filling in, so the pressure of the atrium will overtake the ventricle. Therefore, the AV valve has to open to allow the blood to fill in from the atrium into the ventricle. And from here, we can also identify where is the heart sound. Whenever there's valve closing, there will be your first lump, and this is your dump. And this graph concludes the cardiac cycle. Do join my lesson if you need more understanding on the initiation and the coordination of cardiac cycle. Thank you.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.